Welcome back to SC0X, Week 8, and in this week we're going to talk about statistical tests and multiple random variables, and they kind of work together. So let me give you an overview of what we're going to cover this week. We'll start with statistical inference, and inference is just simply a way of inferring or trying to understand something with your data. And so there's a series of statistical tests that we're going to show you how to do, and you're going to need some tools to be able to handle that. The first thing we're going to talk about is the central limit theorem, and essentially what the central limit theorem says, as my sample size gets bigger, as it gets larger, big, and generally that means more than 30, then I can assume that my distribution is going to follow a normal distribution with some mean and some standard deviation. And we'll go into much more details of this, but the beautiful thing about the central limit theorem is that no matter what the underlying probability distribution of the individual event, if I do many of them, then the sample mean of those is distributed normally. Very powerful result. We'll spend a lot of time on it. Then we'll get into the idea of sampling, because for statistical inference, what I'm trying to do is find out something about the whole population. So if I'm running a coffee shop, for example, and there's 3,000 coffee shops across the country, and I want to know something, I can't sample every single coffee shop. I can do a number of them and then make an inference for the whole population, because rarely can you look at the whole population of your data. So sampling is a technique where you look at a subsample, a subset of your population, and make inferences. So we have to distinguish a couple things here. The difference between the population, and for here, we'll talk about the distribution with a mean and some standard deviation. And when I talk about the sample, we'll use a mean as x bar, and the standard deviation, the sample standard deviation, will be s. And what we want to do is we're going to find these things, find the samples, and then infer what these values are. And we'll talk more about what that means. The reason why we do all this is because we want to make estimates. And when you make an estimate for a population or for any kind of number, you want to know how confident you are. And that's where we get into confidence intervals. And essentially we'll show you how to bound your estimates. So let's say I make some estimate. I want to know how confident am I that my real population value falls within this bounds. And those are known as confidence intervals. And we'll show you how to create those. It's simply going to be that sample mean plus or minus some interval, and I'll show you how to do that. But all we're doing is saying, okay, how confident am I about my estimate? So central limit theorem, we'll talk about sampling, we'll talk about confidence intervals, and this all leads up to the real thing we're trying to do is testing. So a hypothesis testing. It's a very powerful technique. We'll spend a lot of time on it. And essentially what you do is you come up with a null hypothesis, H naught, and an alternative hypothesis, H1 or HA. And they have to be mutually exclusive and collectively exhaustive. So it could be something as that the sample mean does not, it's equal to the mean of another store. And so the two things are equal, and my alternative would be that they're not. And so you have to make things that are collectively exhaustive, so all possible outcomes are there, but they can't fall into both. They can only fall into one or the other. And the purpose of hypothesis testing is to see if you can reject the null hypothesis or fail to reject the null hypothesis. The tricky thing, we'll talk about this, is you can't accept a hypothesis. You can only reject it or fail to reject it. And we'll go into those details a little later. Then we'll shift gears, and we'll talk about multiple random variables, because we've talked a lot in previous lessons about individual random variables and looked at their probability, whether it's continuous or discrete, and the different distributions they may take. What happens if I have two? So for example, what if I am selling two products? Let's just call them X and Y. And this is the number of items sold per day. And what if I have it looking like this? Well, so they kind of move in the same pattern up. Or what if they start looking like this, these little pink dots? They move somewhat in the opposite direction. Or another one, let's see, what if it just looks like this? And this is kind of hard to see. I'll make little X's. So essentially, you've got different ways that they can relate to each other. And we're trying to find the correlation. So when I drew these orange ones that are kind of all over the place, that really had a correlation of 0. There's no correlation. If X moves, it tells you nothing about Y. However, the first ones I were doing, the yellow ones, it was saying that as I sell more X, I'm also selling more Y. Now, I'm not saying it causes it. They just happen to be moving in the same direction. And in that, I'd say my correlation is equal to, or is closing to 1. It's moving in the same direction. And then those pink ones I showed that are kind of moving in this direction, as I sell more X, I'm selling less Y, and for there, you'd find it to be -1. So what we'll introduce you to is a correlation metric and a covariance matrix, but we'll talk about these, and it's a number between -1 and 1, and it just tells you how does one variable move with the other. It doesn't tell you that one causes something to happen, it's just that they happen to move in the same direction or not, or the opposite direction, and that's known as correlation. The last thing we'll do is we'll tie these together and look at when we combine multiple random variables. Because before we talked about if I have random variable X and how do I find the expected value, the standard deviation, all of that. So what if I have a new variable R, and it's actually equal to A, a constant, times X, the number of X products I sell, plus B times the number of Y products I sell. So this is a random variable, this is a random variable. The A's and the B's are just constants. So it could be the price. So $7 for an X and $3 for a Y, whatever. So the question is, what can I say about R? How is R distributed? Can I make any inferences there? What is the expected value of R? And what's the standard deviation of R? And we'll talk about how to do that, because that's when it gets interesting. Individual variables are fine, but when they're combined, that's when it gets interesting, because this is kind of a launch pad for some other more sophisticated tests that we'll do later on. All right, so this is what we're going to cover in week 8. Start with statistical inference, go all the way down to hypothesis testing, shift gears to dealing with multiple random variables, and then we'll be poised to learn all about regression, simulation, and some other techniques. All right, have fun, do the quick questions, try the practice problems.